Hi, I'm Art Hadaway with Water World Magazine. I'm standing on the show floor of WEFTEC 2015 in Chicago, Illinois. I'm standing here with Manny Singh. He is the Senior Vice President of Technologies for Coat Membrane Systems. Manny, thank you so much for joining us today.
Thank you very much, Art.
So Manny, we are standing in front of your brand new, and we're really excited about it, your Pulsion MBR. Let's talk about that.
Absolutely, Art. This is something we're really excited about. This is the next generation of our Puron product. It's something we have been working on for quite some time, and we believe this is going to revolutionize the MBR market. Something we're really excited about. This is the next generation of our Puron.
Hi, I'm Art Hadaway with Water World Magazine. I'm standing on the show floor of WEFTEC 2015 in Chicago, Illinois. I'm standing here with Manny Singh. He is the Senior Vice President of Technologies for Coat Membrane Systems. Manny, thank you so much for joining us today.
Thank you very much, Art.
So Manny, we are standing in front of Hi, I'm Art Hadaway with Water World Magazine. I'm standing on the show floor of WEFTEC 2015 in Chicago, Illinois. I'm standing here with Manny Singh. He is the Senior Vice President of Technologies for Coat Membrane Systems. Manny, thank you so much for joining us today.
Thank you very much, Art.
So Manny, we are standing in front of your brand new, and we're really excited about it, your Pulsion MBR. Let's talk about that.
Absolutely, Art. This is something we're really excited about. This is the next generation of our Puron product. It's something we have been working on for quite some time, and we believe this is going to revolutionize the MBR market.
Now, Manny, what I really want to drive home is the key differentiators of this technology.
Sure. So, Art, if you look at our product here, the two key differentiators which we always had with the Puron membrane was the single header design and central aeration. By that, what I mean is that we do not have a header at the top. The fibers are individually sealed. And secondly, all the air is introduced in the middle of the fiber bundle. So central aeration and single header design was always part of the Puron product. What we did was took that as a base and built upon that differentiator with the Pulsion product. And what we did was two key features. We surrounded the fibers with a cage, that's number one, and we introduced a large bubble which is trapped by those cages. And what the bubble does is it pushes like a piston and removes all the solids out of the fiber bundle. So this schematic explains pretty clearly how that bubble works. Every few seconds that bubble is introduced and pushes all the solids out of those cages, thereby cleaning the membrane, and which allows us to sustain a much higher fluxes.
Great, Manny. And I think what we're going to look at next is how to really incorporate this technology on a larger scale.
That's correct.
And now we're standing in front of the full-scale Pulsion MBR. Now, Manning, let's talk about how this can be incorporated on a larger scale.
Sure, absolutely. Art, what we see here is the full-scale dimensions of a real-life Pulsion MBR. And there are a few key features I want to highlight about this Pulsion. One is it's made up of 8 different bundles, and each of the bundle is surrounded by a cage. And one of the unique features of the Pulsion is how easy it is to access those fibers. So what I'm going to show you is the cages. They are very easy to slide in and out. So by sliding it out, we can easily access each of the fiber on its own without disrupting any other bundles. By doing that, the maintenance, the accessibility of the fiber has been improved significantly. And in addition to that, there's a couple of other unique features. So one is the gap at the bottom here. This gap has been optimized for two reasons. One is we want to make sure it's not too small so that it chokes the recirculation flow. So the gap has to be big enough where the fresh mixed liquor can come into the membrane bundle. At the same time, we can't have too big a gap, because what will happen is the air will start to escape from the bottom. We want all the air to be channeled through the fiber bundle. So that was one of the key features, is how we kind of came up with the most optimum dimensions at the bottom. The other feature here is we have these sludge channels at the bottom, and what that does is allows the free movement of fresh mixed liquor going into the membrane, and at the same time remove the concentrated sludge from the top. So a lot of these features went into play, and in the end we have been testing this product for more than almost a year now. And the performances we are seeing is simply amazing so far.
Sure, and there's no doubt that there's a variety of many benefits to this technology. Let's Let's discuss the value to end users and customers.
Absolutely. I think what this all means is two big savings for the customers. One of them is the energy cost, which is one of the main drivers for any MBR technology right now. As you may know, there's a conventional waste-activated sludge technology and there's a membrane bioreactor. And traditionally, MBRs were considered to be more energy intensive compared to conventional activated sludge. And that was one of the main reasons why that technology was not used widespread across all wastewater treatment plants. By this pulsed aeration system, where we introduce the bubble into that cage, we are able to reduce the energy required for MBR to the level where it's very comparable to a conventional waste-activated sludge. And because that gap is covered, we believe that this really opens up a big market for MBRs, which were not traditionally considered because of the high energy cost. So in terms of savings, this has about 40% savings compared to the previous generation in terms of the aeration rates. There is savings of the footprint. So this one has a 25% less footprint compared to the previous product that we have been using. And one of the ways we have achieved the footprint saving is the whole module right now has a 1900 meter square surface area, whereas the previous generation had 1800 meters square. So that, combined with the higher fluxes we are able to sustain, that makes up the 25% savings in the footprint. In addition to these two savings, customer also sees the value from a simplified system design. I think there's a lot of complexity around the peripheries or the wraparound of the module, which has been simplified with this product.
Now, Manny, are there any other features that you'd like to highlight?
Yes, Art. One thing I want to feature is that the Puron membrane is made of a PVDF coating on a braid. And in a lot of MBR applications, which is a very harsh environment, fiber break has been one of the problems that the industry has faced. So the Puron membrane is made of PVDF coating on a braid, which makes it virtually indestructible. So as you can see here, the fibers cannot be broken. And there's a unique technology that goes behind this. But this feature is extremely important to survive a 7 to 10 year life in a typical MBR operation.
Great. Well, Manny, really appreciate your time today. Thank you so much. And where can our viewers go to learn more?
Absolutely. They can visit our website at www.cokemembrane.com, or they can always send me an email at msing@cokemembrane.com.
And for Water World Magazine, I'm Art Hadaway.